This is the third mini-lecture for section 6.1 of the textbook. Let's keep talking about equivalent fractions. Okay, we just saw that two fractions are equivalent if they represent the same amounts. So they may not be the same fraction. Like 2/3 and 4/6 are different fractions because they have a different numerator and different denominator. But they represent the same amount, so we would say that they're equivalent. Now, the fundamental law of fractions tells us that a over b is equivalent to a times n over b times n, where n is any integer. So, for example, 2 over 3 is equivalent to 2 times 2 over 3 times 2, which of course is 4 over 6. Or again, 2 over 3 is equivalent to 2 times 3 over 3 times 3, which is 6 over 9. And I could keep going like this. 2 over 3 is equivalent to 2 times 4 over 3 times 4, which is 8 over 12. And it doesn't have to be positive either. The n does not have to be positive. So, for example, I could do 2 over 3 is equivalent to 2 times, I don't know, -5 over 3 times -5, which would give me -10 over -15. Okay, so the fundamental law of fractions tells us that. Okay, this is one way of showing that fractions are equivalent, but obviously it doesn't apply to everything. For instance, I know that 4 over 6 and 6 over 9 are equivalent to each other, but this rule doesn't help us show that really. Okay, so we need a little bit more than that. So not every pair of fractions is related in this simple way. But one thing we can always do to see if fractions are equivalent is find a common denominator. So we can use the fundamental law of fractions to write a over b as ad over bd and c over d as bc over bd. Those are equivalent if and only if the numerators are the same. So because the denominators are equal, the fractions are equivalent if and only if the numerators are also equal. Okay, so this is called the cross product property. A over b is equivalent to c over d if and only if a times d is equal to b times c. So for example, 4 over 6 is equivalent to 6 over 9 because 4 times 9 is 6 times 6. Yeah, they're both 36. Okay, so often when we want to use a fraction for something, we want it to be in simplest form, which basically means that the numerator and the denominator are as small as they could possibly be. So technically speaking, the fraction is in simplest form if a and b share no common divisors greater than 1, and the denominator b is positive. So we just want, if we have a fraction, maybe we got it from doing some kind of computation, and we want to use it to measure out some oil for a recipe, or cut a board for something that we're making, a table or something. You want to make that work as easy on yourself as possible, so you want to put the fraction in simplest form first. You want to replace the fraction with an equivalent fraction that is in lowest terms or simplest form. So let's think about the number 300 over 720. We can put this in simplest form by applying the fundamental law of fractions repeatedly. Okay, 300 over 720. Well, 300 is 30 times 10, and 720 is 72 times 10. So using the fundamental law of fractions, see, that's 30 over 72. Okay, now let's see. 30 is is 15 times 2. 72 is 36 times 2. So you get 15 over 36. Again, by the fundamental law of fractions. "15 is 5 times 3. 36 is 12 times 3. Fundamental law of fractions tells us that that's 5 over 12. And then 5 and 12 share no common factors greater than 1. So that's in simplest form. So in all, we used the fundamental law of fractions 3 times here. Okay, so this is the method that you probably resort to when no one makes you do it a different way. It's kind of the guess and check method. It always works. Often it's not the fastest way to do it, and sometimes it's hard to tell if you're really done. 5 over 12, it was easy to tell that we were done. But, if we weren't as good at dividing, or if we ended up with some weird numbers at the end, it might be hard to tell whether we were really done with this process. So let's talk about a couple other ways to do this. Okay, this helps reinforce some things we learned last semester. So we could simply divide the greatest common divisor out of 300 and 720 all at once. There are lots of ways of finding the greatest common divisor. One way is to use the Euclidean algorithm, which I'll do just for practice. So you all thought maybe you could forget all about it, but no, you still have to use it. Okay, so 300 goes into 720 twice. We have 120 left over. 120 goes into 300 twice, with 60 left over. 60 goes into 120 twice again, but now there's 0 left over. So that means that 60 is the greatest common divisor. So 300 over 720, I can rewrite by factoring out that 60. That's 5 times 60 over 12 times 60. And then the fundamental law of fractions says that that's 5 over 12. So the point of doing it this way is that when I divide out that 60, I'm dividing everything in common out all at once. And I know that there's nothing that's left at that point. Okay, now the third method is to use prime factorizations. So instead of figuring out the GCD on its own, we could just use the prime factors. Remember, we used primes to figure out the GCD last semester. But we could use that same idea directly here and just divide out the common primes. So let's begin with a couple factor trees. Get 300 is 30 times 10. 30 is 5 times 6. 10 is 2 times 5. 6 is 2 times 3. So 2, 3, and 5 are all prime. Okay, 720 is 72 times 10. 72 is 9 times 8. 10 is 2 times 5. 9 is 3 times 3. 8 is 4 times 2. And 4 is 2 times 2. So I didn't really leave us enough room here, but we'll squeeze it in. So 300 over 720. That's 2 times 2 times 3 times 5 times 5. That's upstairs. Then downstairs we have, let's see, 4 2's. 2 times 2 times 2 times 2 times 3 times 3, oops, times 5. Okay, now here's where I apply the fundamental law of fractions a bunch of times at once. I can just remove everything they have in common. Which leaves me with 5 over 2 times 2 times 3, which is 5 over 12.